explaining the syllabus of core course 14 CBCS course semester 6 carbohydrates. In carbohydrate, following topics are there: classification of carbohydrates, constitution and absolute configuration, establish the structure of glucose and fructose, conversion of glucose into fructose and fructose into glucose, explanation of terms like epimers, anomers, mutarotation, etc. Structure elucidation and configurational and absolute configuration of disaccharides like sucrose, maltose, elementary treatment of polysaccharides like starch. Thank you. Classification of carbohydrates are two types. One is classification into monosaccharides, polysaccharides, oligosaccharides, etc. And second one is reducing and non-reducing sugar. In first case, monosaccharides, for example, glucose, fructose, etc., are the carbohydrates which on hydrolysis give only one type of carbohydrates. None of monosaccharide on hydrolysis can give more than one type of carbohydrate compounds. This is the simplest one. Whereas oligosaccharides are those carbohydrates which on hydrolysis give 2 to 10 types of or 10 units of monosaccharides, such as sucrose, which gives 2 monosaccharides. Maltose also gives 2 monosaccharides. When we are considering polysaccharides, these carbohydrates on hydrolysis give a number of monosaccharides. Second type of classification, reducing and non-reducing. Those carbohydrates which reduce Tollens reagent or Fehling solution, both of them are mild oxidizing agent, are reducing sugar. That means the carbohydrate which on adding Tollens reagent get oxidized, that means it is reducing sugar. For example, all monosaccharides are reducing sugar, such as glucose, fructose. All these are reducing sugar. When Tollens reagent or Fehling solution is added into sucrose, it does not get oxidized. That means it is a non-reducing sugar. Thank you. Question is asked in carbohydrate chapter. Establish the open chain structure of glucose. To establish the open chain structure of glucose, you have to establish molecular formula, presence of aldehyde group into it, presence of 6 carbon in a straight chain, presence of 5 OH group in which one of them is primary OH. When you will prove all these, you can establish the open chain structure of glucose. groups. Let us start one by one. Molecular formula by different methods determined for glucose is C6H12O6. When we are considering the presence of aldehyde group, when glucose is treated with HCN, that means hydrogen cyanide or hydrocyanic acid, it gives cyanohydrin. It means it shows there is carbonyl group. Similarly, when glucose reacts with hydroxylamine, that is NH2OH, it forms oxime. It also confirms that glucose contains one carbonyl group, because with NH2OH, that means hydroxylamine, aldehyde and ketone both give oxime. So carbonyl containing compound react with hydroxylamine to give oxime. Phenylhydrazine is also one of the reagents which confirms the presence of carbonyl group. So when phenylhydrazine treated with glucose, it gives glucose pentylhydrazone, glucose phenylhydrazone. All these reactions, that means reaction 1, 2, 3, all these reactions suggest the presence of carbonyl group into glucose. Short reactions are given here, and glucose is first treated with HCN, then second one NH2OH, then third one phenylhydrazine, and you can see the reaction of them. On the mild oxidation with bromine water is a mild oxidizing agent. So when glucose is treated with bromine water, it gives gluconic acid. This confirms that the carbonyl group in glucose must be aldehyde. Thank you. 5-hydroxy group in glucose molecule. When glucose treated with acetyl chloride or acetic anhydride. Acetyl chloride is CH3COCl, or acetic anhydride is CH3CO whole 2O. Acetic anhydride is dry acetic acid. A pentaacetate is formed. It means each molecule of glucose reacts with 5 molecules of acetic anhydride or acetyl chloride to form glucose pentaacetate. Thus, glucose contains 5-hydroxy group. Since glucose does not lose water readily, each hydroxy group must be present on a different carbon atom. It is a rule in chemistry that if in a molecule single carbon, that means on same carbon atom, more than one OH groups are present, it will be unstable. That means that molecule will be unstable and it will remove H2O molecule immediately. That means no organic compound having 2 or more OH group on the same carbon atom is stable. In that sense, here it is said that glucose does not lose water readily. That means glucose molecule is stable. Each hydroxy group must be present on different carbon atom in glucose molecule. That means 5 OH group must be present at 5 different carbon atoms. Presence of 5 hydroxy group and 1 aldehyde group is further confirmed by the fact that glucose on reduction with sodium amalgam and water, it gives sorbitol, which forms a hexaacetate on treatment with acetic anhydride. It means glucose molecule on reduction gives sorbitol. This sorbitol, when reacts with acetic anhydride, it gives sorbitol hexaacetate. Next one, presence of one primary hydroxy or alcoholic group. It means in glucose there is one primary OH group. That means one of the OH group is present at primary carbon. For this conformation, glucose on oxidation with nitric acid gives glucaric acid. A dicarboxylic acid containing the same number of carbon atoms as glucose. One of the carboxylic group is glucaric acid must have been produced by oxidation of aldehyde group, and other must have been obtained by the oxidation of primary alcohol. Thus, one of the 5 hydroxy group present in glucose must be primary OH. Fifth one is presence of a straight chain of carbon atoms in glucose. Glucose on reduction with Hi and red phosphorus at 100 degrees Celsius give a mixture of N-hexane and 2-iodohexane. This indicates that 6 carbon atoms in glucose are in a straight chain. Since glucose cyanohydrin on hydrolysis and subsequent reduction with Hi and red phosphorus gives 1 heptanoic acid. This also confirms a straight chain of 6 carbon in glucose. Now we have established that in glucose molecule, 1 is aldehyde group, 1 primary alcoholic group, and altogether 5 OH group, 6 carbon atom in glucose are present in a straight chain, and formula of glucose is C6H12O6. On the basis of all these evidences, we can write the structure of glucose like this: CH2OH, single bond, CHOH, single bond, CHOH, single bond, CHOH, single bond, CHOH, and single bond, CHO. Above structure of glucose is confirmed by its oxidation with hydroiodic acid, that means HiO4, which consumes 5 molecules of HiO4 per molecule of glucose and produces 1 mole of formaldehyde and 5 molecules of formic acid. In terms of mole, we can say that each mole of glucose consumes 5 mole of HiO4 to give 1 mole of formaldehyde and 5 moles of formic acid. Conformation of D plus glucose. Here we are considering D plus glucose. It means the D plus, these two symbols represent the stereoisomeric structure. of glucose. The open chain structure of glucose contains 4 chiral carbon atoms. Therefore, by formula 2 to the power 4, total 16 stereoisomers must be there. Optically active stereoisomers are known. These 16 exist isomers are in 8 pairs of enantiomers. 8 belong to D series and 8 belong to L series. Out of these 16 stereoisomer, one is D plus glucose, which is written below. Considering the limitation of open chain structure of glucose. Limitation, in another word, we can say demerits in the open chain structure. That means in glucose sample there may be some ring chain or some other structure of glucose than open chain structure. Here we are just considering some reactions on the basis of which it will be confirmed that glucose may have open chain as well as a ring chain structure. One of the reactions given here, free aldehyde, a molecule having free aldehyde group forms crystalline sodium bisulfide with sodium hydrogen sulfide. But in case of D plus glucose, crystalline sodium bisulfide with sodium hydrogen sulfide not formed. Similarly, a molecule having free aldehyde group responds to Schiff's reagent test, but in case of glucose, Schiff's reagent does not react, or glucose does not respond to Schiff's reagent. Similarly, a molecule of a compound having free aldehyde group reacts with hydroxylamine to form oxime. But in this case, glucose reacts with hydroxylamine, of course, but glucose pentaacetate does not react with hydroxylamine. These are 3 evidences. Fourth evidence is a compound with free aldehyde molecule reacts with 2 molecules of methanol to form acetal. But glucose forms isomeric methyl glucosides. Normally, 2 molecules of methanol react per mole of aldehyde to form an acetal. But glucose, when treated with methanol in presence of dry HCl gas, it reacts only 1 mole of methanol to form a mixture of 2-methyl D-glucoside. That means methyl alpha D-glucoside and methyl beta D-glucosides. These glucosides do not reduce Tollens reagent and phthalate solution and do not undergo mutarotation. All these reactions confirm that there are certain limitations, certain discrepancies in open chain structure of glucose.